A statement from Neil deGrasse Tyson. The universe isn't just greater than we can envision. Under most scales, it is greater than we can envision. Does the universe have an end and a start? And has the James Webb Telescope at last found the edge of the discernible universe? Since the days of yore, we have needed to know how huge the world we live in is. We carefully look for limits and insights, and in doing so, our insight has kept on extending. In the past, the edge of the world was someplace past the skyline. Today, we use telescopes to scan the universe for signs that show us whether our universe is a limited space. We may now have accomplished a conclusive leap forward in this rudimentary question with the James Webb Space Telescope. Whether or not the universe has an edge isn't an inquiry, it positively has one, but we don't have the foggiest idea whether this edge is really the finish of the universe or of creation. An edge could also resemble a limit that leads into another universe or into already obscure aspects. Our Earth additionally has an edge, as do the planetary systems. Nevertheless, the universe doesn't end there. Neil deGrasse Tyson is totally right. The issue with the size of the universe is in our minds and not in the actual universe. The universe is greater than we can envision. We can look for the start and end somewhere out there or in time, and we still use similarly unobtrusive tools to do so. With our telescopes, we are already looking around 46.5 billion light-years toward each path, which means we are checking in total width out of around 93 billion light-years. Up to this point, there has been no foreseeable endgame, and the mass of stars, galaxies, and phenomena that we have tracked down in this space is beyond imagination. If it would take us millennia to explore each side of the universe that we know, we are still driven by an insatiable curiosity to continue looking endlessly further. We want to know whether the universe has an edge and what it looks like, and the JWST should finally show us this edge. Does the universe have a starting? A statement from Neil deGrasse Tyson. The James Webb Space Telescope distinguishes objects in the dark. These, as per the best estimations we have, are huge, completely evolved worlds. We humans are stupid as far as we're concerned. Everything has a start and end, and we usually naturally think in terms of facts and figures, as well as spatially restricted and bound structures. Anyway, anyone who deals with the universe soon comes up against the limitations of thought and perception. To understand the inconceivable aspects within the universe, most of us need to extend the constraints of our insight. The sheer size of what we see so far, the number of stars, the innumerable planets, and the most unusual cosmic phenomena, push a limited and restricted mind to open up. Space experts and cosmologists should therefore be among the most receptive and imaginative individuals, or so one would think. However, our researchers these days have to understand that they too are still very limited, and that thinking within limits has kept them from recognizing the true reality of the universe. The JWST is now pushing our space specialists to their limits. Theories and bits of wisdom are wobbling, and it's very possible that our perspective will take another leap, just as it did many years ago when people realized that the Earth is round, not flat. James Webb shows us 6 galaxies that are so old and so perfectly developed that they shouldn't actually exist in the early universe. The JWST was designed to investigate the Dark Ages, where the first stars were formed. However, instead of showing us the normal protostars and young galaxies, the telescope serves us endless rows of perfectly formed and extremely old-looking galaxies. So, are we really looking at the beginning and thus the temporal edge of the universe? Or, more completely, did the Dark Ages truly exist, or did we humans just make it up because we didn't know the truth? The 6 galaxies are by no means the only stunning discoveries made by James Webb. The telescope also found an enormous group of galaxies that existed too early for them to be in the universe groups. A great many galaxies meet up in gatherings, and until now, we believed that individual stars were formed first, then star clusters, later galaxies, and then universe clusters. What does a group of galaxies that existed when the universe was still very young have to tell us? Countless galaxies with a redshift greater than 10. A statement from Neil deGrasse Tyson. The issue isn't the universe. The issue is us because we assume we know more than we really do. It sounds insane, but the JWST is still showing us more galaxies at once than the dark ages of the universe. Practically all the galaxies in the early universe that Webb found have a redshift of more than 10, meaning they existed when the universe was 2% of its present age, just a couple of 100,000 years after the Big Bang. These discoveries don't show us a dark world yet, but a universe that really looked much like it does today. These revelations are so mind-blowing that scientists initially questioned Webb's discoveries. But the spectroscopy of the telescope has confirmed each result several times over. Spectroscopy has played a crucial role in confirming the distance and properties of the very distant galaxies. Astronomers use this technique to break down the light of a cosmic object into its various frequencies and, subsequently, determine the age of the light source and physical properties like its composition. Organization Webb's outcomes showed that these cosmic systems are extremely old, as well as likewise contain components and various stars that don't fit with a youthful universe. The worldly edge of the universe is at present moving further and further away from us. However, shouldn't something be said about the spatial edge? Have we previously tracked down it, or might we at any point find it? Here we face a mystery. Since, supposing that we are searching for something in a space that exists now, we would need to see this space in real time. Imagine you are searching for the walls in an extremely huge show hall. It's dim, with the exception of a couple of little LED lights a good ways off of 10 or 20 meters. You don't know precisely how huge the room is, nor can you see the walls. You would need to, look for the edges by feeling your way around. This choice is unrealistic for us in the universe because we can't go through it personally right now. The other choice is that you have a telescope, with which you look endlessly further. You center around the brilliant spots, or in other words, where the LEDs are, because you would be able to see a bit there. If your telescope is adequate, you may be able to detect the walls of the room at some point. However, the interesting thing about the universe is that it's moving at the precise moment we are looking with our new super telescope, the JWST. It's as though the walls of space are extending while you are looking, so you need to ensure that you stay aware of the development of the walls as you develop your telescope technology and reach in space. We experience another peculiarity that makes the quest for the walls or an edge more difficult. Light takes time to travel through space. With the JWST, we see light that has traveled 4 light years, 100,000, or even 13 billion light years. So, we just ever see the past. Rigorously speaking, you also see the past in your room, but the light from LED 60 or 100 meters away only needs a negligible part of a second to reach your eyes. So here, we can say that you experience space continuously. However, in the universe, the temporal aspects are various. We can currently see the closest star, Alpha Centauri, as it was quite a while back. Obviously, we can say that the universe probably was even more modest 400,000 or a long time ago, since it hasn't expanded that far yet. We have not yet succeeded in tracking down any indications of a spatial cutoff. Rather, we have found proof that the universe isn't growing at the same rate everywhere. This could imply that our universe doesn't have a uniform, homogeneous structure but is organized in a way that we have not yet perceived. JWST's flight into boundlessness. Have you at any point believed that it may be a mistake to search for limits or a start? Maybe this new time of space exploration needs to show us that we need to quit thinking in terms of restricted aspects, to go beyond what we have viewed as real so far. In its own peculiar way, the JWST shows us over and over that there appear to be no restrictions even within the universe. Again, the telescope found structures that break limits, and it wasn't even about looking for an edge. James Webb investigated a far-off system and viewed as such an enormous dynamic cosmic focus that researchers were stunned at the focal point of this youthful world, somewhere around 570 million years after the Big Bang. A quasar with a black hole multiple times the mass of our Sun was previously seething. Black holes that are part of a functioning cosmic core transmit an unusually huge amount of light, which is produced by the friction of the material streaming into the black hole in a twisting motion. Such cosmic centers shine trillions of times more brightly than the most brilliant stars. Indeed, even as it continues looking for exoplanets, the JWST is continually showing us that we should quit thinking about limits. We should make progress toward variety and limitlessness to comprehend the universe. HIP 65426b was already identified by Hubble in 2017, but now, because of Webb's novel new capacities and extremely delicate spectrometers, we have even more clear information from this far-off world. HIP 65426b is a colossal gas monster, around 12 times bigger than Jupiter. It's found a good ways off from its star, 100 times more prominent than the distance from Earth to the Sun, over 2 times as far as the dwarf planet Pluto is from the Sun. Using Webb's coronagraphs, cameras, and different channels, this planet has been imaged directly for the first time, which is an absolute exception, as most exoplanets are found by transiting in front of their home star or by indirect techniques. These are only 2 limits, and 2 additional instances of the reality that we need to deal with the fact that there are so many peculiarities, eccentricities, exceptions, and ever-new aspects to find in the universe. It would be absolutely silly to search for an end, edges, or limits. Subscribe to the feed now and be part of every new video feature.